Okay, we're going to go through annuities today, and we have two formulas. And if you have a TVM solver or a financial calculator, it'll make things a lot easier. But we're going to talk about what each of these things mean, and there are a lot of variables. Both of these are technically the same. Okay. You'll notice A, which stands for the total amount of an annuity. So how much money you'll make over the life of this annuity. R stands for regular payment. So how much money you put in every period. Okay. I is the compound interest rate. And to calculate I, we take the interest rate, which is this R, and we divide by the compounding period. And we'll talk about what a compounding period is. To the power of n. N is the number of periods. To calculate the number of periods, we take the number of years that this annuity is going to be on for, so whether it's a 5-year annuity, a 10-year annuity, and we again multiply by compound period. We divide it by I, and that's again how you calculate I. So whether you want to use one formula or the other, it's fine. If we use this one, realize that we have to calculate for n and I before we can plug it in. In this formula, we can take all of the raw data and plug them directly in. The calculations are a part of this. Okay, so I'm going to give us an example of why we would use it. So let's say we have a bank account, $600 in our account. Or actually, better yet, let's say we're working a job and we're able to save money. We'll say we're able to put away $100 every single month, which is probably a reasonable amount for you guys, right? So we're going to say we're able to put $100 a month away into a bank account. If you go to a savings account at the bank, they don't have an idea of what kind of interest rate they would give you. 7%. That's very nice. Yeah, it's probably very, very low. 100%. We're going to say something like a 1%, okay? But what we'll say is this is a 1%, okay, per year. It's not a lot of money. And what we'll say is, you'll notice you guys get interest how often? How often do you guys usually get interest?
Per year.
Per year? They usually give it to you a month. A lot of times in a bank, they'll give it to you per month. So we're going to say that it's compounded monthly. Compounded. Okay. And we'll have to know the difference between monthly, annually, semi-annually, quarterly. We'll talk about those later, okay? So here's a bit of information. And let's say, how long do we plan on working for? Say we're going to do this till we retire. Yeah. How old are we? 17? When are you going to retire? 65? Okay. So how many years are we going to do this for? 65 minus our age of 17 right now. Anyone know what that gives us? 48. Good. 48 years. So that's not terrible. That's an S. Okay? So, we're going to do this for 48 years. So what we're going to do now is we're going to talk about what each of these are in reference to our formula, this information. So, if I'm going to be putting in $100 every month, which of these do you think that refers to? Every month I'm going to put in $100. Regular payments, that's right. Those are our regular payments. We're going to be putting $100 in every month. So our R are our regular payments. In your TVM solver, they may ask you something like that. Okay? 1% per year. Okay? That's strictly the interest rate. And to figure out the I, which is the compound interest rate, we have to divide it by the compound period. What is our compound period per year? How many times is this interest compounded per year? 12. That's what monthly means. It means that it'll be 12 times a year. So we know this is going to happen 12 times a year. So we're going to take our 1%, and according to this, we have to divide it. What is 1% as a decimal? 0.01 divided by 12. Okay? Anyone know what that's going to be? We need a calculator for that one. 0.01. There are 3 zeros in front of it. Is that what it is? 0.12383 repeated? Yeah. Okay, so a very small decimal. So for our sake, it'll actually be much better if we type this in as a fraction. especially if you're putting it into your calculator, because we want to get as much money as possible. We don't want to round down here. Okay? So this is our compound period, or this, here stands for our I. We just calculated I. We took our interest rate and we divided by how many times a month we would get interest. Okay? The next number we need to figure out. So we've now accounted for our R. We've accounted for I. We need to figure out N. N is the number of total periods over the life of the annuity. And to calculate N, we take our years and we calculate it by, again, the compound period. So how many years do we say we're going to do this for? 48. And we're going to do this every single month for 48 years. So we're going to take 48 and multiply it by what number? That's right, 48. And we're multiplying by the compound period, which is 12. How many times will this occur, the number of periods? We'll take 48. 500. Did I do that right? Yeah. 576? Okay, so we're going to do this 576 times over the life of this annuity. So every month we put in $100. So by the time we retire, we'll have done this 576 times. That is enough information to now type into this formula to figure out how much money we'll have when we retire. Okay? So we'll take this formula. A is what we're trying to find. A is the total amount. We want to know how much money we'll have at the end. So we're solving for A. Our R, remember, was our regular payments, okay, was $100. So we have 100, and we're going to be multiplying by 1 plus, what was our I value? So our I value, we said we're going to keep it as a fraction just because typing in as this decimal will be very complicated. So in our calculators, we'll have to type it in as this fraction here. Okay? And really what this says is we get 1% a year compounded 12 times. We're actually making a little more than 1% a year. What this is doing is it's giving us a certain amount of money, and then every month we're getting interest on the amount of money in the bank. So because our amount grows, we earn more and more and more interest. And this is important. The more compounding periods we can have every year, the more money we're actually going to make. Okay? From that formula, it goes to the power of n. What was n? It was the number of periods. How many were there? How many times were we going to do this over the life of the annuity? 576. So this is a huge power. 576. And at the very last, we subtract by 1. Okay? And all of this is divided by... Sorry. This bracket's in the wrong spot here. Okay, should be like that. We have that all set up properly? Yes, good. Good. Okay. And finally, it's all going to be divided by 0.01 divided by 12. So on your TVM calculators, I'm going to go through this just using a calculator, solving one piece at a time. Try to solve this with your TVM solver. We've talked about what was important. Try to plug those values into that calculator and see if we can get what we're trying to do. I'll work through this the old way. The old way, this is a bracket. Okay, so I got to deal with what's inside my brackets first. So I have 1 plus this value. Okay, so my next line is going to read A is equal to 100. And this is going to be 1.00083 repeated. We already did that part of the fraction. This value is going to go to the power of 576 minus 1, all divided by this. The next thing we're going to do is deal with our exponent. So we're going to take this base to this exponent. That's a very large exponent. So I'm going to take 1. Okay, so we have this number in our calculator. We need to put it to the power of 576. So I'm going to put this to the power of 576 equals 1.615. Okay, we'll round it to 1.615. So our next step in our calculator, that shouldn't have came up. Okay. Sorry, this will become 1.615. So A is equal to 100 times 1.615. I think it was 75. It continued. and we have to subtract 1 from that value. Okay? And the way I got that is I used my calculator, remember? And I put it to the power of 576. So 61575, that's good enough. We're going to subtract that. When I subtract that, are any of the numbers after the decimal going to change when I subtract 1 from this? No, just the 1 is going to disappear. So I don't even really need to type that into a calculator. I can do that on my own here. So I'm going to simplify this bracket. A is equal to 100. This bracket, because this is 1, subtract that number, becomes 0.61575. And all of this is still divided by that fraction. That fraction is the last thing we're going to do on the bottom. I need to multiply this. Luckily, I'm using the number 100. Does anyone know how to multiply 100 by a decimal very quickly without typing it in? Yes, that's right. We're just going to move this over 2 places. So the number on top is then going to read 61.575, all divided by a fraction. So this is a little hard to do on your calculator. You might want to actually figure out what that fraction is. I'm going to show you how we would do it. I take the number 61.575. I divide it, and I put my brackets. Divided by bracket. So you see my bracket is up here. 0.01 divided by. So it's writing the bottom part in brackets, which is very important. 12. End bracket. So this is my top line. This is telling me what that little bracket is equal to. I hit equals. And this is how much money we will have. $73,890. $890. So, by putting in just $100 a month, which is a really small amount once you start to make a large amount of money. If I were to do this from the age of 17 until I retired at 65, my account would be holding almost $74,000, which is a pretty good amount of money considering we only put in $100 a month. Okay, so to continue from there, this was the amount of money we made. I want to actually figure out how much money I personally put into the bank, right? It's not like they just gave me 73. I actually have a certain amount invested. How much money was I putting in every month? $100. How many times did I put $100 in? 576. So let's figure it out. We actually put in 576, because that's how many times we did it, times our value of $100. We put in 57600. We ourselves actually put in $57,600. So, how do I figure out how much interest I earned? Yeah, we subtract these two. So we take this value. In the end, our account said $73,890. And we subtract the actual amount we personally put in from our money to figure out how much interest. Okay? So, 6. Is that right? So we earned $16,000, almost $300 in interest. So quite a bit of money still. $16,000 in interest. They gave us $16,000 in interest. Okay? It was a long time, and the reason was we had a very low interest rate, and we didn't really put in a lot of money. If we had increased the amount of money, say we put in $200 every month, we would have earned more interest over the life of this. We also would have had a lot more money.